For 37 years, Uranus got away with it. It sat out at the cold edge of the solar system, a smooth, pale, blue-green marble. No storms, no stripes, no weather worth the word. We looked at the one good photograph we had, shrugged, and filed it under boring. The planet nobody bothered to visit twice. That photograph came from a single night, January 1986. A spacecraft called Voyager 2 swept past about 50,000 miles above the cloud tops, took its pictures, and kept going into the dark. It never came back. Nothing has been back since. So for an entire generation, that one bland portrait was the whole story of Uranus. Then, almost 40 years later, the James Webb Space Telescope turned to look, not in the light your eyes can see, but in infrared, in heat. The calm blue marble dissolved. What came back through the lens was not a quiet world at all. It had been awake the whole time. We just never had eyes good enough to catch it. This is the planet we called dull. It was never dull. It was hiding. We almost didn't find it at all. In 1781, a musician named William Herschel was sweeping the sky from his back garden in England with a telescope he'd built himself. He spotted a faint disk and assumed it was a comet. It wasn't. It was a new planet. The first ever found through a telescope instead of the naked eye, and overnight it doubled the size of the known solar system. Even its own discovery had to be dragged out of it. That turns out to be the pattern. Uranus gives up its secrets only when something forces them out, and every secret has been stranger than the last. Start with the one fact that poisons everything else. Uranus is lying down. Every other planet spins more or less upright like a top. Earth leans a modest 23 degrees, just enough to give us seasons. Uranus is tipped almost 98 degrees. It isn't spinning. It's rolling on its side like a bowling ball shoved down the lane of its own orbit. Something did that to it. The leading explanation is a collision, an impact with an object the size of a small planet early on, hard enough to knock a world clean over. And here's the part that matters. It never got back up. 4 billion years later, it's still on its side. Hold on to that, because almost everything that makes this place a nightmare traces back to that one blow. Lying on its side wrecks something we take completely for granted. The day. Because the poles are tipped toward the sun, they take turns pointing almost straight at it. Uranus takes 84 years to go around once, so each pole gets roughly 21 years of unbroken daylight, then roughly 21 years of unbroken night. Sit with that. Born at one pole, you could live a whole human life and die without ever once seeing the sun rise or set. Just a long, dim glare that never moves, and then 2 decades of dark. And dim is the right word, because Uranus is far, almost 1.8 billion miles from the sun, 19 times farther out than we are. Out there, sunlight is roughly 400 times weaker than the light you're sitting in. Noon on Uranus is darker than the last grey minute after sunset on Earth. There's no real daylight there, just a slightly less complete kind of darkness. You'd assume the farthest planet is the coldest. It isn't. Neptune sits farther out and Uranus is colder. In fact, Uranus is the coldest planet in the solar system. Full stop. Its upper atmosphere drops to about minus 371 degrees Fahrenheit. The coldest temperature ever recorded on Earth, deep in Antarctica, is around minus 128. Uranus beats that by more than 240 degrees. What's strange is that Neptune, even deeper in the dark, runs warmer. Neptune pours heat out of its own core. Uranus barely does. It leaks only a faint trickle of warmth from inside, far less than any other giant. as if its furnace had been turned down to almost nothing. Why is still argued over. The prime suspect, again, is that ancient collision, a blow that may have sealed the planet's heat deep inside, trapped under the surface where it struggles to escape. Say you survived the cold, the air would still find a way to kill you, and it would be rude about it. In 2018, astronomers in Hawaii finally read the chemistry of the upper clouds and found them thick with hydrogen sulfide, the gas that gives rotten eggs their smell. The planet quite literally reeks. One of the scientists put it about as dryly as you can. Anyone unlucky enough to descend through those clouds would meet very unpleasant and, his word, odoriferous conditions, though the suffocation and the cold would finish them off long before the smell became the problem. A frozen, airless, rotten egg sky. And we still haven't reached the strange part. Which brings us back to James Webb. When Webb looked at Uranus in infrared, the dead world from 1986 lit up like a crime scene under a black light. Where Voyager saw a blank face, Webb saw a bright cap of haze sitting over the North Pole. Inside it, a vast bright spot, a single enormous storm, a polar vortex turning slowly at the very top of the planet, smaller storm clouds scattered around it. It had been doing this the entire time. Every year since that flyby, the weather churned up there in the dark and we simply couldn't see it. The planet wasn't quiet. We were blind. Webb caught something else. Uranus has rings. Most people have no idea. They're nothing like Saturn's, thin, faint, made of nearly black, sooty material that drinks light instead of reflecting it. There are 13. Webb pulled 11 into a single frame, down to a ghost faint ring called Zeta we can barely detect at all. But here's what stops you. Because the whole planet is tipped on its side, the rings don't lie flat around its waist. They stand straight up. From our angle, Uranus looks a target, a black bullseye standing upright in space. The planet a glowing dot at the center. A world does not tip itself over and stand its own rings on end. Something out there did this. The vertical rings are the fingerprints it left behind. Webb went hunting for moons and found one nobody had ever seen. Uranus now has 29 known moons. In early 2025, in Webb's images, a team picked out a tiny new one, only about 6 miles across, tucked in close among the rings. Voyager flew right past it in 1986 and missed it completely. It hid in plain sight for the whole span of the space age, and it took the most powerful telescope ever built to drag it into the light. The moons have a strange dignity. They're named not for gods like the rest of the sky, but for characters out of Shakespeare and Alexander Pope, Titania, Oberon, Ariel, Uriel, and the small battered one called Miranda, a frozen court of literary ghosts circling a king knocked on his side in the dark. Miranda is where it gets personal. It's less than 300 miles across, a cracked, dirty snowball of a moon, and on it stands what may be the tallest cliff in the entire solar system, a wall called Verona Rupes that drops as much as 12 miles straight down, more than twice the height of Everest, in one sheer face. Now stand at the edge. Miranda's gravity is so feeble that if you stepped off, you wouldn't fall the way you fall on Earth. You drift downward slowly for around 10 minutes before you reach the bottom. 10 full minutes of falling, in total darkness and total silence. No air to carry a sound, no scream to hear even if you made one. It's tempting to file Uranus away as the freak of our solar system. The rest of the galaxy disagrees. When we look at the thousands of planets we've found around other stars, the single most common kind isn't a Jupiter, and it isn't an Earth. It's a world about the size of Uranus and Neptune, which means this tilted, frozen, rotten egg oddball might not be the exception at all. It might be the standard model of what a planet is. And Earth, the warm blue rock under your feet, the rare freak in the crowd. So far we've stayed above the clouds. Go below them and the last familiar thing falls away. There is no ground. You couldn't crash a spacecraft into Uranus. You'd sink into it. The gas just thickens and thickens until the pressure would crush a ship like a soda can underfoot. Most of the planet isn't gas or rock at all. It's a vast, hot, electrically charged ocean of water, ammonia and methane. Thousands of miles deep, hot enough in its depths to rival the surface of a small star, yet squeezed so hard it can't boil. No shore, no seabed, no bottom you'd recognize as a bottom. And in that ocean, it rains diamonds. I'm not being poetic. The methane down there is packed with carbon. The pressure and heat tear that carbon loose and crush it into crystal. Actual diamonds, heavier than the fluid around them. They sink in a slow, endless storm toward the core. We've recreated it in a lab, firing lasers into the right materials and watching tiny diamonds form in the shockwave. The most beautiful thing in the solar system, falling forever through the most hostile place we know, where no eye will ever see it. There's one more, and it might be the eeriest of all, because it's a symptom of how deep the damage runs. Most planets have a magnetic field that runs neatly pole to pole, roughly lined up with the spin. Uranus's field is tilted almost 60 degrees off its axis. Worse, it isn't even centered in the planet. It's shoved off to one side, so that as the world rolls, the whole field lurches and wobbles around it. When Voyager measured it in 1986, the readings were so bizarre that scientists argued about them for years. It tells you the chaos isn't skin deep. Whatever hit this planet didn't just knock it over. It scrambled it all the way to the heart, and 4 billion years later, it still hasn't found its balance. And here's the part that should keep a scientist up at night. In 2024, researchers went back through Voyager's old data and noticed something unsettling about the day it visited. The spacecraft had arrived just after a violent gust of solar wind, a blast of charged particles from the sun that slams into Uranus only about 4% of the time. It caught the magnetic field, crushed and contorted into a shape it almost never holds. Show up a few days earlier, and Uranus would have looked like a different planet. Almost everything in the textbook about this world rests on that one flyby, and we may have caught it on the single strangest day of its life. We don't really know Uranus. We know one photograph of it, taken at the worst possible moment. Here's what should bother you most. Everything I've described we know from essentially one source, a single spacecraft one night 40 years ago. We have rovers sending back high-definition video from Mars every day. We've flown a probe past Pluto 1 billion miles farther out, but our close-up knowledge of Uranus has been frozen since 1986, the year of the Challenger disaster and the first Top Gun. There's finally a plan. A dedicated mission to orbit Uranus and drop a probe into that rotten sky has been named the top priority for the next great planetary mission. But it would take well over a decade just to get there. Some of the scientists dreaming it up will retire before it arrives. For 37 years we looked at the calm blue marble and called it dull. We were wrong, and not by a little. It was never dull. It was just out of focus, a world rolling on its side through permanent twilight, the coldest place we've ever found, where the air rots and the rings stand on end and it rains diamonds into a bottomless sea. All of it set off by a single blow it took before life on Earth had even begun. It makes you wonder what else we've written off too soon. The universe doesn't always hide its monsters in the dark corners of deep space. Sometimes it leaves one right out in the open, painted a calm and pleasant blue, waiting for us to stop laughing and finally pay attention. And when we go back, when something of ours finally settles into orbit and sees this planet on an ordinary day, I suspect Uranus has a few secrets left. The kind that ruin your sleep,